So I'll have this here. All right, so I came all the way from the Canary Islands, that's a community in Spain, to discuss this vision for power systems planning. And who am I to have a vision about anything? So I'm an electrical engineer by training, and also I have a master's in reliability and an MBA, and I've been in this business for a while, doing SCADA systems, programming, market consultancy, and now I work for the Spanish TSO. So yeah, vision for power systems planning. But you know, I just gave you some credentials, but this is my real credential. This is my portfolio. This is what matters. This is what says I'm for real. And the first thing that I have there is one project called GridCal. I'm going to discuss that briefly, but I have also other projects there. So Redeia is the umbrella company where the Spanish TSO is located. For reference, the Spanish TSO was the first modern TSO, as we know it, in 1985. We were also the first ones to have an independent control room for renewables in 2006. We handle about 50% renewables daily with 70% peaks. And I come from the innovation company of this umbrella shell called Elewit, and it's like a massive R&D department with a hedge fund attached. And we invest in innovation, and we channel all the innovation of all these companies. I have been giving versions of this presentation around, and I think it's best if I tell you what's about up front. And you will conclude all these things at the end, but I tell you right away what they are. So you will conclude that planning in power system demands making a lot of studies. And what's a study? So whenever a renewable plant wants to connect to the grid, someone like me has to crunch the numbers. And all across the board, we crunch the numbers using closed source energy software. And that, my friends, is a bottleneck. So open source can be a way out. You will conclude that along with me during this presentation. I have been very involved in R&D in my career, so I can tell you that all solutions don't solve new problems, and R&D is needed, but how can you put R&D in something that you don't own? So open source allows R&D, yeah? And now the most important message that you will hear, and that is, Excel is not a database. There you go. So I need to tell you something else before really starting. So it's the value of reinventing the wheel, and this comes from the learning of karate. So at the beginning, you are in the stage of ha. So in the West, we call that the academic stage, and you copy what the master says. And you don't ask questions, you just copy what they tell you. Eventually, you graduate and you go into the world, and you start being in the state of shu. And in the state of shu, what you do is apply your academic knowledge to the real world, and hopefully you reflect on that. And when you reflect for long enough, you'll become Mr. Miyagi. You'll have the knowledge and the experience to tell when the academic knowledge is applicable and when to produce new academic knowledge, right? So you are free to do as you will without overstepping the laws that you learn. But what is power systems planning anyway? So it is the process of proposing new infrastructure for the grid. And you do that attending to technical, social, and economical principles, all of them together, oftentimes putting monetary value to those that do not have it, such as the social one. It's not strictly required, but often is needed to do it like that. So in my career, I've seen ways of doing things. And the first one is scenario analysis. You will hear this, and you have heard this for sure. So we figure out what's going to happen in 2050, and we know it for sure. For sure, 100% we know it. You know? And then we do all the planning for that. We do all that's necessary, and we are very strict in planning for 2050. But you know, this is a fragile approach, because small changes in the assumptions make big changes in the conclusions. Something else that I've seen happening is something that I want to call consensus analysis. So we extend this scenario analysis, but looking at things from many different places. So the environmental one, the market one, the dynamic analysis one, power flow one, short circuit one, a number of ways. And you have many people involved looking at the same thing and making the conclusions robust. By doing this, you want to have your conclusions insensitive to changes in the inputs. But what if we do something else? We stress test things. Huh? And by stress testing them, we want to become anti-fragile. This is a very strange concept. So if something fragile happens when you change it and it breaks, what happens if you change something and it improves, right? So there's an electrical study that does this, and this is the adequacy analysis. So we stress the grid, and every time we find a terrible failure in the grid, we fix it. With our electrical engineering magic, we do something, and we do that millions of times, you know, until we eventually have a process where failures make the grid better, right? But what are we doing? We are very deep into scenario analysis. So this is a picture from the European network of transmission companies called the NSOE, and this is what coordinates the European planning. So every country has their planning, but there's also a macro Europe plan. And we have scenarios, for sure, right? And NSOE claims that for the last planning season, it was spent 1 million hours in simulation. For context, that is 114 years of simulation time. And I say 114 years of what? Of doing market analysis and then checking that market analysis, which is a very simplified way of looking at the grid. We check that with a more detailed physics simulation. And of course, we exchange program A with program B using what? Excel, my friends. And all this is done by hand. No unified database, no unified software. It is hard to technify because replacing these closed source softwares is really, 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 really hard. And Excel reigns supreme. So in 2020, I made a survey for my MBA because I wanted to learn about these things. So is this only happening in Spain? Is it only happening to me? What's going on? So I interview ISOs here from North America, also Mexico and Canada, and TSOs from Europe, and also ISOs and TSOs from Asia. And I concluded that 75% think it is very labor-intensive to collaborate with others in modeling. No surprises there. 80% think that tools are not ready to deal with more renewables in the grid. And bear in mind, these are the people doing the number crunching for connections. And 80% think the stuff they're using is not fit for purpose. So, of course, 74% of the people that I interview are involved in software development somehow because they want to fix all this stuff from different approaches. And I was very surprised to learn that 95% would accept open source if there was proper support. So business people in the room, there's a business. Yeah? So I'm going to tell you briefly about the story of GridCal. So this is the park of Clarendal in the city of Arnhem in the Netherlands, and I was working the building in the back, you know. And by the way, that letters there says research brings light. So I was doing that, researching to bring light, you know. And I was doing stochastic algorithms, which for those of you that do not know what it is, it's like trying things randomly at scale. And I was using as a calculation engine a very well-known closed source program. And I found out that 98% of the simulation time was setting the values in the program, which I find outrageous. So I contacted the company, and the answer they gave me, after a lot of back and forth, was, yeah, that's life. That's life, my friend. You have to wait 4 days for your simulation, where you could wait half an hour. So, yeah. So I went running to my boss's room, Theo, and I told Theo, I have to write my own power flow. You know, I have to do it. I cannot be waiting forever. I'm a millennial. I want things now. And Theo was a very knowledgeable man, and he told me, Santi, you are not going to do that in company's time, because you know what? People like you did that in the 90s, and they failed. So I'm not going to allow you to fail again with the, the money of the company. So I told him, all right, but what if I do it in my own time? So he said, sure. We signed the papers, and I started researching. And after a couple of years, I had a version that I was using in research. So yeah, I was the fool working in his own spare time to make his work better, you know? So I was working like 2 or 3 times. But eventually it worked. But Theo was warning me about the do-it-yourself trap. So whenever you have to do something related to software, you go to the vendors and they offer you probably what you want to do. But eventually, you want to add more functionality to that software that you don't own, because that's the nature of electrical engineers. We want to do things. And if the source is not available, we end up in a very expensive place where adding functionality is super expensive, so it becomes a vendor lock. So what if you do it yourself? You know, you are arrogant enough to think that you can do it. So you start investing. You invest a lot at the beginning. And if you do it right and do all the steps and you behave, you end up in a payback tale where adding functionality is like Mr. Miyagi picking flies with the chopsticks. Very easy. But Theo was warning me about something else. He was warning me about this. You can make all the investment and still end up with garbage. And that's a real thing. I've seen it through all my careers. I've been working in a couple of multinationals. In all of them, happens something like this. And this is where the managers tell you, go back to commercial software, because the risk is lower. So why do multinationals fail to do what I did in my spare time? So I can tell you right away, there's no substitute for passion. That's the #1 thing. But the power system market is small and saturated. It's a red ocean. So there's little incentive to put a lot of money into these planning softwares. So it's small but profitable. So why do we do it, right? So when someone starts doing these softwares, this gravitates towards the mentality of having it close so that competitors don't steal your research. There's also no real technical audits, just market fit. So whenever you do things, you are like a hero in a company doing this by your own. Like John McClane in Nakatomi Plaza, and suddenly the people and managers see that you have something, they want to sell it, and that's that. There's also a gross amount of lack of information, so everything becomes R&D. I have spent thousands in electrical engineering books, and I can tell you 0 of those books, 0, have the correct formula of the flow of a line, 0. They all have approximations, but not the real thing. And in a corporation, there is project work, and projects must deliver something for the market. You are not allowed to start small. Ha, shu, and ri. Right? So in 2019, I started working in the planning department of Red Electrica. And of course, we were moving Excel files around. From software A, software B, and by the way, it's way more complicated than this. So I measure the amount of money we were spending by decision, and it was about 9,000 euro. And a group of us thought, yeah, this is insane, what we're doing. So why not simplify this? So we came up with how it should be. So having a single source of truth, the software should be all integrated and do everything that we need to do, and there should be a single way of reporting. So this, in theory, was 13 times faster, of course, millions in productivity. And do you think it was right away introduced in the flow? Of course not. There's a crusade to be made. There's a technological conquest. People are very used to the tools that they already use. So I figured we need a killer app. So what was the killer app for us? Eventually, the Iberian Peninsula is joined to France through a set of mountains. Every investment to connect to France is super expensive, super expensive. And those connections are decided by big boards between RT and Red Electrica. And at the time, RT had a very good tool to calculate that in an optimal fashion, and we didn't. So I figured, why not starting having it and put that application inside the open source software that I've been developing, right? So in 4 months, we went from formulation to using the software, and the people involved remember that time as the best time they have had in their professional careers, you know? Because it worked, you know? We had this functionality, and it really worked. So from there, people started buying into the idea of using this open source for planning and having all these killer apps be built into it. So eventually, we have invested in new types of database, integrated modeling, all these cloud pipes, and reporting, new types of investment algorithms. So what's the vision, right? What am I here to speak about? So I've been telling you stuff, but what is it? What's the vision? It is to produce a framework to make the technology that enables the change. Because people in regulation in the room or watching this, regulation comes from technology, not the other way around. It is a bottom-up thing. Of course, now you have concluded that planning demands making a lot of studies, right? Also, closed source that is used across the board is a bottleneck for us. So open source can be a way out. All solutions don't solve these new problems. We need R&D, and to put R&D into something, you have to have the source, right? So open source again. And Excel is not a database.
In a world driven by energy, every decision we make shapes the future. That's why we have made GridCal the one-stop shop for power systems planning. GridCal isn't just software, it's a platform for you to achieve your planning goals. With a comprehensive suite of tools, including AC/DC multi-grid power flow, optimal power flows, investment analysis, and a state-of-the-art database, GridCal empowers you to tackle the most complex challenges with confidence. But GridCal isn't just for experts, it's for everyone. It is free and open source, breaking down entry barriers and fostering innovation and collaboration across the globe. Adapting to the changing landscape of energy, GridCal is your trusted ally in navigating the complexities of modern energy systems. Validated by academia and industry, it's a tool you can rely on. And with seamless integration of third-party engines, GridCal delivers unmatched performance, allowing you to achieve results faster than ever before. It's a software thought for productivity, from simple scenario simulations to the latest and most relevant research. Get started today with GridCal.
The revolution will not fight germs that may cause bad breath. The revolution will put you in the driver's seat. The revolution will not be televised, will not be televised, will not be televised, will not be televised.
Yeah,
the revolution
open source will put you in the driver's seat.
The revolution will be live.
So I believe there's some time for questions, if there are any.
Thanks, Santiago. This is awesome. Did you consider, I guess I'll just start with one, when you look at, as you mentioned, some of the stress testing things, it seems to me there's a parallel between that and, say, in modern software systems, this concept of chaos engineering, right? Yeah. And are there any parallels that can be learned from that we can kind of build into this platform?
Absolutely. So actually, a big part of my current research is how to think in that way, because the scenario approach, when you do backtracking, it almost never fulfills. So you need to, yesterday it was said that you need to enable all these energy transition things. And I believe it's a very good way to have this chaos kind of thinking and have redundancy built into the grid. And this is a way to discover where redundancy is needed. We are also into the idea of having the grid very well utilized, but there has to be an equilibrium between the two, because you need reliability as well. So the more uncertainty you have because of renewables, you also have to counterbalance with reliability of the grid. So these methods need to be baked in.
All right, I guess if nobody else is going to take it, I have another one. Have you thought about, I think the theory of open sourcing a lot of these planning things and allowing for innovation is fantastic. If as part of this project, have you done much work in thinking about architecture, especially how the architecture be extended, right? Because it seems like people want to pile on different kinds of things, different use cases, different ways of planning, specific ones like your example with the mountains, that makes a ton of sense.
Well, the program, I made it such that's very easy for let's say, untrained users to use it, but expert users can, the whole backend is made in modules. So you can extend modules kind of easily. And that's something we do more or less on a daily basis. I try to teach other companies how to use this and provide services for us using this technology, and they eventually create modules. So if you're a PhD or a master student, actually I have 3 master students working with this. There's a bit of training at the beginning, but once you get it, it's very, very, very easy and rewarding to put these modules into it. And also to extend, to have AWS pipelines, all that is quite simple to make.
Hey, great talk. I love hearing about other, system operators. It's like catnip for energy market nerds. When you're working on this, an open source project, developing systems to solve in an area where the data is typically very restricted, right? It's either CII, secured, whatever. It's difficult to acquire. You have to prove you have certain credentials. How, as you're out here, right, looking for uptake and more interaction with people in other markets, other countries, other companies, have you seen that sort of barrier to the data you need to feed into the model? You have a great solver, but if you don't have an approximation of the network, right, how does, if you could talk about that at all.
Well, I try to make the program read anything that you can get into it. So either it be SIM, PSCC raw, Powerwall, Power Factory, I try to be compatible with that, and that lowers the barrier of entry for any person. But if you are in, let's say, academia and you want to test your algorithm, I have found that there is only one difference, and that's the quality of the data. IEEE data is flawless. Real data is terrible. So having synthetic data is really good, but I think it will be really good also to have data sets with failures, with mistakes in it. So then you figure out that your algorithm really works in real life, and there's no other difference I found.
Yeah, makes sense.
Congratulations for the talk. I was wondering if you could tell us more about how was your experience building a community around this new model. I mean, how did you coordinate with the team? Because I feel this is the most challenging part of building an open source model.
Yeah, so I was discussing yesterday that you need to have 2 things that are very rare here. So you need to be an excellent programmer, and you need to be an excellent electrical engineer. And that's the conjunction of both is there are very few people for this. I have found that motivated people get into this eventually. So, PhDs, they have to do something, or masters, they are forced to do innovative stuff. And there's a bit of an entry barrier, and that's on the IT side. But, I'm here to help, so I do that. Lately, I've been creating more of a community in the universities in Spain, trying to have more and more PhDs reuse their work because they bake it into this thing. Aside from that, I have 10 commandments, and the number 1 commandment is that perfection is the only thing that is excusable tomorrow, So I want that mindset in my people, because otherwise, if you start having these bad decisions or lazy decisions in software, you end up in garbage, and I really don't want that. But I'm really friendly, I really welcome people, and I give tutorials and extensive hours of training if needed, because I think this is a valuable thing to have.
Okay, thank you.
So I'm a bit new to the world of power systems modeling, so I just wanted to confirm how this relates to other systems. So the focus seems like it's on power flow analysis and not capacity expansion or production cost. Is that right?
Those are some pieces, yes.
And so how do you think about this integrating with the market analysis tools? Because this covers just the grid analysis, right?
Well, I designed this specifically to be a replacement for the market tool. So this does market and electricity seamlessly.
I see. So can you say, like, we want to reach certain goals by 2050, what should the investment decisions be as well?
Yes, and we made something, an investment module that tells you the Pareto curve, which is far better than usual what you get in these softwares.
Oh, very interesting. Okay,
Yeah.
thanks.
I believe time's up, so I'll be around, so good.